Hey guys, Dimitar here with another code review. I think you're gonna like this one. It's a Python function, but you don't have to be a Python developer to extract some key takeaways here that will help you become a better developer all around. So I found this function here. It's a Python function. I made up the class, but it's part of some class because it's a private function. And just looking at it, it is bad. It is really bad. And this is a production function written by real developers, real engineers. And this business probably makes millions upon millions of dollars. Okay, it's a hotel business, so they make a lot of money. And yeah, if somebody has to come in and make a change here, it's going to be very, very dangerous. So let me show you what this is about. And by the way, if you're not a Python developer, you're still going to get a lot out of this. So stay tuned. So we have a get availabilities function. And you notice here, I'll just give you a brief look. You can have a brief look, and then we'll go back to the problems. I have a for loop here. We make some API calls. We try catch, right? And then we return. So what are the problems? The first problem is it's not deterministic. Remember, every function you write should be deterministic. This means it should have an input and it should have an output. And regardless of how many times you run the function, it should always return the same result. This is what deterministic means, okay? And how do we break this? How have they broken this here? Well, they make an API call. They make an API call smack dab in the middle of a for loop. This is not good because this API, maybe they do not control it, maybe they wrote it, but it's an HTTP call. It has to go over the wire, fetch some data. There, we don't know what's happening here. It's bad. If you want to test this function, well, you have to basically mock the API instance in the constructor. I haven't written the constructor here, but you get the point. You have to mock it, and testing becomes really difficult. And you mix logic with HTTP calls. It's not good. Okay. The second thing is I already mentioned that you have to mock the dependencies. Okay. We have a branch. We have an if here that returns nothing. So at the bottom, you notice we return the result, and here we return nothing. So the caller has to account for that. Okay, it it's just bad. I don't know what to tell you. It's just bad. And let's see the fourth one. We have a try catch very deep in the code. This is a private function, remember? And there's a try catch here. And what are they doing? They're updating something. So let me get this straight. It's a get function, and you're writing to the database. This is this breaks all the principles. I mean, it's yeah, right here, writing in a read-only function. Don't do that. If it says get, it should not modify anything. Period. No modifications of any sort. And then we have logging as part of the implementation. I think they do logging here in the basically this should be its own function, the try catch, because it does a check and then updates if the check is valid. Update something, set the room count, right? Um, Yeah, you should do the logging. You should not have the logging as part of the business logic. That's not your core logic. Logging should happen outside after the result has been computed, after you've done some work, then you log, okay? Not as part of it. I'll show you later. So these are six things just in this tiny function, and this is a nightmare to maintain. It's not maintainable. It's not good. Like you're afraid to make even a single change here. So let's see how we can improve that. Again, we have get availabilities, and you will notice it's now much smaller, okay? And let's see, get placeholders. So getting into the nitty gritty here, the main logic of this function resides right here in the placeholders. And then they use the placeholders to make an API call, and then they populate this slices list. Okay, they stuff it with slices. basically. So instead of making a single call every time the loop runs, why not just pre-compute all the placeholders, right? There, you'll see here, we return early, but we return an empty array. It's a good default. It's an empty array. Because we're returning an array, if the default happens, well, we return an array. And then we calculate the placeholders. This cannot fail. This is deterministic. Given these inputs, you're always going to get the same outputs because we don't touch an external database or an API or anything like that. So you can test this now. Now you can test this. Okay? Remember it. Okay, we get the placeholders. And now this is the root function. Okay? If it were me, if I were writing this, I would because this is a private function, and this class is going to have a root function, right? Some sort of an API, external API, so other clients can call it. I would stick this even further up top, okay? But in this example, you see how we just basically try to push the external calls, the dangerous calls. You try to push them as far outward as possible. If you imagine the core of your app should be safe. This is your business. It should be safe. And you push the dangerous stuff around it, okay? At the very outer edge. That's where you stick all those nasty API calls and database calls at the edge of your app. The business logic should have nothing to do with API calls, okay? It just needs behavior and data. That's it. Behavior and data. You don't need API calls there. So we make the API calls, one for each placeholder, and now we have the data, right? And here in get availabilities v2, no, I actually forgot to delete that. That the availabilities are the data. Sorry, the slices are the availabilities. That's what it happens, right? If you see, if we collapse this, you'll notice the slices are the data in the get availabilities. Sorry, my bad. So here we return something very readable. The caller is going to know, okay, these guys return availabilities. And as I mentioned, because we do not write in a get function, we just maybe we do just a calculation, okay? Should we update the room count? Should, and this now is a boolean. And then the client can say if should, then update with this data. Okay, very simple. But again, this is a definitive result. It's not a database call. We're not doing this where they where's that? Where they update the actual database, right? This is a database call. No, we get rid of the try catch. Let the caller, let the client handle the nasty logic. Okay, this way you push the dangerous stuff to the outer edge of the app, and this is very testable now. Okay, should update room count, get placeholders. So you see, even in production systems, nasty stuff happens. Like I don't know how the internet works, but this it's riddled with code like this. Do not write code like this, especially number one. Your code should be deterministic. Always push the dangerous stuff to the outer edges. Okay, I'll see you in the next one.